We want to figure the volume of a cylinder. So that is like a trash can or a lampshade or a can of beans, okay? Now the top part of this, if I was looking straight down on the top part of this would be a circle. And since it has a circle, it has a radius of the circle. This is the distance from the center of the circle to the outside. It's called the radius. All right? And the second thing we know about this is the can or the can of beans or the cylinder has a height to it, okay? The cylinder has a height to it. The trash can is so high, the can of beans is just so high, so we have a height to this can. It goes from here to say there, all right? All right, now the volume is the area of the bottom or the top times the height. And the bottom or the top of this looks like a circle, okay? And we know the area of a circle is pi times r squared, all right? So there's your circle, all right? Looking straight down on it, it'd be a perfect circle. Right now it looks like an ellipse looking at it from the side. But the base is the bottom or the top of it, and it looks like a circle. And the area of a circle is pi times r squared, okay? So the volume of this is the pi r squared, and this is the way you write that, r times the h. There's your formula, where you're going to plug in the radius twice, and you're going to plug in the height. All right, and we're going to use 3.14 for pi. So there's your pi r squared h, pi times r times h, and here we're going to fill in the values for it now. Pi is, we're going to use 3.14. We know that's not pi, but for the purposes of this problem, we're round pi off to be 3.14. We plug in the r, which in this case is the radius, which in this case is 2.5 centimeters twice. And then the height is 6 centimeters for this problem. All right? Now, if you multiply these numbers, you're going to have 117.75, and you're going to have centimeters times centimeters times centimeters. We'll write cubic centimeters this way.